All right, now we're going to talk about something you haven't seen before. Oh, big, there we go. We are going to look at radian measure. Now, radian measure is just another way to measure angles. Just like we've always done it in degrees, this is just another measure. Just like when we take a look at, how far is it from Edmonton to Calgary? We can measure it in either kilometers or miles. So with angles, we can measure them in either degrees or radians. Now, what is a radian? Well, if I take a look at the radius, let me get a color here, of a circle, we know that that is a radius and this is a radius. And if I took this length and bent it and put it right on here, like that, that would be 1 radian. So when we take a look at radians, it's approximately 57 degrees. But we talk about radians because of its relation to the circumference of a circle in terms of pi. So if I have a circle and I want to, I didn't want that, there we go. From here to here would actually be pi radians. So if you take a look in this circle on the left here, I could fit about 3 radians in here. Here's one, here's one, here's one, and it's exactly pi radians. So 3, and we know it's approximately 3.14. So here's 1, 2, 3, and a little bit, but it's exactly pi radians. So that makes a full rotation 2 pi radians. Well, and up here, if I went halfway, that would be a half a pi. And if I went all the way down here, that would be a pi and a half, which is 3 pi over 2. So you can see the relationships we have here. All right, any angle that does not have a unit following it is considered to be a radian. So, for example, if I say an angle has a measure of 3.2, if I don't put the degree sign, we assume it's radians. So if you're telling me that an angle has a measure of, let's say, 62 degrees, you got to make sure you put the degree sign. So if you don't put the degree sign, we assume it's radians. So for example, on an exam, if you gave me an answer of 62 and forgot to put the degree sign, unfortunately, we wouldn't be able to give you full marks for that. Now, you're going to be expected to be able to convert from degrees to radians and from radians to degrees. And you kind of just have to know this because these two formulas are not on your formula sheet. So let's take a look at a couple examples of how to do this. So convert from degrees to radians and give your answers in exact value terms in terms of pi. So I'm going to go ahead and say 125 times pi over 180. And that will give me 125 pi over 180. But what we need to do is we need to reduce that fraction. And a little trick is just to put 125 divided by 180 in your calculator, and you can go math, enter to reduce the fraction. When you're doing that, just don't put the pi in there or else it's not going to work for you. So when I do that, I end up with 25 pi over 36. So there's my exact value answer in terms of pi. I'm going to leave the next one for you, and then I'm going to go ahead and do this one. So convert from degrees to radians to the nearest tenth. Note that they're not asking for an exact value. So I follow the same process to start, but I just put it in my calculator, 72 times pi over 180 and one sweeping motion, and I end up with 1.3 radians. and I'll let you do number 2 on your own here as well. Okay, now we're going to go from radians to degrees. So I'm going to use this relationship up here, and I'm going to take 5 pi over 12, and I'm going to times it by 180 over pi. And if you take a look, the pi's actually cancel out here. So all I need to do to the nearest tenth is put 5 divided by 12 times 180 in my calculator, and I'll end up with 75, and I'm going to put that to 0.0 because it's asking to the nearest tenth degrees. I'm going to leave number 2 for you, but I'm going to do number 3. So if I have 1.57 radians, again, the conversion factor is times 180 over pi, and I end up with just putting all of that in my calculator, including the pi, because the pi's don't cancel here, and I would end up with 90.0 degrees, and make sure you're putting that degrees in there. All right. All concepts can be found using degree or radian measure. So what does that mean? That we're going to be looking at coterminal angles with radians, and we're going to be looking at reference angles with radians right now. So coterminal angles are the same terminal arm that can be separated by a multiple of 360 or 2 pi, because that's the conversion. One complete rotation is 2 pi radians. The principal angle is the smallest positive rotation angle with the same terminal arm. The principal angle is between 0 and 360 degrees, or between 0 radians and 2 pi radians. Okay, well, let's take a look at what's happening here. So with reference angles, if I have a quadrant 1 reference angle, whether it's degrees or radians, we know the reference angle in quadrant 1 is always equal to the rotation angle. Oh, sorry, we'll just say it's equal to the reference angle. Number 2, if I have, let me grab a different color here. If I have something here, let's think about that in degrees. If I am given the reference angle and I need to find the rotation angle, that gives me 180, and then I have to back up and minus the reference angle. That's where we got this. So to do that in radians, we're going to go pi minus the reference angle. And in quadrant 3, remember, if I'm given the reference angle here, I go 180 plus the reference angle to give me the rotation angle. So that would be pi plus the reference angle. And the last part here, think about it in degrees. If I have a reference angle here, I'm going 360 degrees minus the reference angle to give me the rotation angle, this guy right here. Well, to do that in radians, I would go 2 pi minus the reference angle. So this is, how we find the rotation angle in radians. All right, let's try an example here. Draw the angle in standard position. State the principal and reference angle. List one positive and one negative coterminal angle, and write an expression stating all angles that are coterminal with the given angle. All right, so 5 pi over 12. That is in quadrant 1. And you're saying, how do I know that? Well, I know that here is pi over 2. That's a half a pi. What does pi over 2 look like in radians with a denominator of 12? If I'm thinking about an equivalent fraction here, that would be 6 pi over 12. So we can see that 5 pi over 12 would end up in quadrant 1. So we've drawn the angle in standard position. State the principal and reference angle. Well, the principal angle is the first positive one, so we know that the principal angle, oops, I'm just getting used to drawing pies here. I meant to say I'm answering part 2 here. State the principal and reference angle. Well, the principal angle is 5 pi over 12, and the reference angle in quadrant 1 is the same. List one positive and one negative coterminal angle. All right. Well, we know to find coterminal angles, we need to add or subtract full rotations. So I'm going to take the principal angle and I'm going to add a rotation. And I'm going to take the principal angle and I'm going to subtract a rotation. Well, now we're going to get good at fractions again here, because we love fractions. And I'm going to find a common denominator of 12, because that's what's common here. So that would be 5 pi over 12 plus, and I'm timesing both top and bottom by 12, so I get 24 pi over 12, and that would give me 29 pi over 12 as my positive coterminal angle. And I'm going to follow the same thing to find my negative, except I'm going to subtract the rotation. Oops. And that's going to give me negative 19 pi over 12. And the last question, this is a big one, it's asking, write an expression stating all angles that are coterminal with the given angle. So let's go ahead and do that. That would be taking the principal angle, adding 2 pi n. So that is multiple rotations because we're multiplying it by n, and we just have to say, hey, n's an integer, so we get full rotations. I'm going to let you try part B, and you can check your answers. I'll be back.